All right, let's dissect this paper on Trans-LoRA. It tackles the problem of transferring low-rank adapters, LORAs, between different base language models without needing the original training data. That's a pretty big deal for practical applications. What's the core innovation here?
The core idea is using synthetic data generated by a large language model, LLM, to bridge the gap between source and target models. Instead of retraining LORAs from scratch on the original, often proprietary, data, Trans-LoRA leverages a synthetic data set that approximates the original data distribution. This allows for transferring the learned parameters, the LORA, to a new base model.
So you're essentially creating a proxy data set. But how do you ensure this synthetic data is good enough to maintain performance? Isn't there a risk of significant performance degradation?
That's the crucial part. Naive synthetic data generation doesn't cut it. Trans-LoRA introduces a discriminator model trained alongside the original LORA on a small subset of real data. This discriminator acts as a filter, ensuring only high-quality synthetic samples, closely resembling the original data distribution, are used for transfer.
Interesting. So the discriminator is trained on real data, but the actual transfer happens using synthetic data. What kind of LLM is used for both generation and discrimination?
The paper uses instruction-tuned LLMs for both the generator, creating synthetic data, and the discriminator, filtering it. Interestingly, they found that using the target model itself as the generator worked well, and the discriminator trained on the source model generalized effectively to various target models.
That's a clever approach. What about the scale of this synthetic data generation? Does it impact performance?
The paper shows that Trans-LoRA scales well with the amount of synthetic data. Generating more filtered synthetic samples generally leads to better performance, offering a trade-off between accuracy and computational cost.
Let's talk about the experimental setup. What models and datasets were used?
They evaluated Trans-LoRA on Llama 2 and Gemma model families, using datasets like Big Bench, HARD, BBH, Massive Multitask Language, Understanding, MMLU, and others covering a wide range of tasks. They tested within and across model families and even different PEFT methods, LLM, DoRA, prompt tuning.
And what were the results? Did it actually work as intended?
Yes, remarkably well. Trans-LoRA consistently achieved lossless or even improved performance compared to both the source LORA and the target base model. This indicates a positive transfer effect, where the combined knowledge surpasses the individual components.
That's impressive. Were there any limitations or failure cases?
The paper identifies a few cases where the synthetic data generator failed to capture the task's nuances, leading to slightly lower performance. They suggest increasing the number of real samples used to guide the generator as a potential solution.
So the quality of the synthetic data is paramount. How do they measure the quality of the synthetic data generated?
They used maximum mean discrepancy, MMD, to compare the distributions of filtered and unfiltered synthetic data with the original dataset. The results showed that the discriminator effectively reduced the distance between the filtered synthetic data and the real data.
What about the computational cost? Is this method significantly more expensive than retraining?
While Trans-LoRA requires synthetic data generation, it avoids the need for access to the original training data, which can be a significant logistical and privacy hurdle, especially in commercial cloud settings. The paper doesn't provide a direct computational cost comparison, but the authors suggest it's a worthwhile trade-off.
This seems like a significant advancement in parameter-efficient fine-tuning. What are the broader implications?
Trans-LoRA opens up possibilities for more efficient and scalable deployment of customized LLMs in cloud environments. It addresses the challenge of model updates and allows for centralized management of numerous client-specific LORAs without compromising performance or violating data privacy.
What about the future directions mentioned in the paper?
The authors mention exploring direct PEFT transfer without the intermediate step of synthetic data generation, which could further improve efficiency. They also highlight the need for more robust methods to ensure the synthetic data generator accurately captures the task's intent.
So to summarize, Trans-LoRA offers a novel approach to transferring LORAs between base models using synthetic data and a discriminator. It's a promising technique for practical applications, particularly in cloud-based LLM services. What are your overall thoughts on the paper's contribution?
It's a significant contribution to the field of parameter-efficient fine-tuning. The clever use of synthetic data and a discriminator to achieve nearly data-free transfer is innovative and addresses a critical practical challenge. The extensive experiments and ablations provide strong evidence for its effectiveness. However, further research is needed to address the limitations related to synthetic data generation and to explore more efficient transfer methods.
This is a great discussion. Thank you.